Okay? This is very important. This is the safety interlocks. The machine's laser will not fire if this door and allow you to fire the beam. Okay?
Will you even get a red beam with it open, or no?
Yes, you will. You'll get a red beam, but you won't get the real laser.
It's like the lid in the front.
It's the same. Very good. No, thank you.
Yeah.
The top door or the front door. If the doors are open, you'll get a red beam, but you won't get the real one. It's for safety. Okay? Because if we did not interlock this door, we could effectively take the laser off while it was still plugged in and do graffiti on the wall. Like this. I didn't tell you that, okay? You know what I did one time?
Oh.
Alright, enough of that. Okay, so you can see the wires here, and there's the power supply. Now, if you look, you got the big cables coming out, the red and the black, 48 volts DC. If you wanted to, you could take your two probes and go across these two screws here like this. There, and these two screws like that to measure 48 volts, but you can easily go off the connector. It's the same connection. This little connector here is the one that goes to the fan. Okay?
This offshoot here.
This little one off the side goes directly to this fan. So as soon as you turn on the power supply, that fan's going to kick on right there.
Go ahead.
Got it? Mm-hmm. You can see that in this particular configuration, there are actually two power supplies, one here and one there. In order to get enough power, we have to put two together and bunch them. On the X machines that can do up to 120 watts, we actually have up to 4 power supplies ganged together in order to produce enough DC voltage, DC amperage.
Of that same size?
Yeah.
That must be a pretty
That'd be
big
2
machine.
pack. Yeah. We'll take this and gang them up here, and so it'll be like 4. It'll be a big box. If even one of these power supplies were to go out, you just replace the whole thing. The whole thing comes out like a module.
This whole thing here.
Yep. Let's show you how to take it out.
But a standard
Because that's going to be the next question.
Is it special power?
No, it's absolutely special.
How about
Is
those
it-
harnesses? Do they ever go bad?
No, don't worry about a harness. The only reason why you would ever worry about a harness is if there's chemical corrosion inside the machine, like that company,
Or
Thomas
good old-
Electric.
How about a good old mouse?
That's it.
I got in
Must
trouble
have
for
mice
that.
damage every now and then, no?
Mice damage?
Well, I mean,
That
mice
could.
are just horrible. I mean, I give them gravy machines, they chew everything up.
Yeah, hopefully not. Well, if they're running around there, you try to hit them with the beam. That'll be quite exciting.
Fried mice?
Okay, let's show you how to take the power supply out. If there was a power supply problem, there are 5 screws to take out the power supply in this particular model. There's one right here, this lonely little black one right there. We'll take that one out. And then there are 4 screws on the bottom, so you have to kind of get the door out of the way. And there are 4 screws down here. 1, 2, 3, and 4. So we're going to go ahead and take those out. Now it's rare that we've ever replaced power supplies, but it can happen. It's not impossible. We've got like a failure, especially these power supplies, called SSIs. They're a different manufacturer. We've been putting these in ever since the platforms. We've had about 3 failures and about 3,000 supplies, so it's less than 20%.
Did they have it specially made for your application?
No, they're not specially made. They are standard power supplies, but you just can't go down to a hardware store and get them.
Right.
They're special order. They're high wattage, 600 watt power supplies.
Wow. That's pretty high.
Yeah. 3, 4. So now we got the 4 screws out. The whole thing will come out, as a module like this. Once we get the screws out, open the cover back up, and it slides right out. Very simple. See? Here we go.
So what's that?
These are the power supplies. So you can see how there's 2 here. The inputs go into here. The outputs come out of the other side. Here's your power switch here. There are 2 fuses that are in here. To get those 2 fuses out, you just take a small screwdriver in this little slot and pop it out. Because if you've got power in, but you don't have power out, there may be a problem with these 2 fuses. However, if you go and you can attempt to replace the fuses, and if they pop again, obviously there's something drastically wrong with the power supply. It's shorted. So let me get my little tool. How am I just going to use this? See if I can pop that out.
expect our
You
customers
need a little
to do
screwdriver?
this.
No, we don't. No, I'm showing you guys just how it works.
A little
Customers
room.
aren't expected. I have my toolkit.
No, but when they order a new power supply, then
Okay.
Like take my wallet home if I drop it.
Okay, there we go. There's our
Such a
fuses.
homophobe.
Now, sometimes they have little extra ones in there for you. It depends who's working that day, you know? So, if you get lucky, you got a couple extras.
That's pretty nifty.
There they are. You can check a fuse by taking a meter. Usually these meters come with a continuity checker, like this, CONT, with a little beeper on it. No, I'm fine. Chairs are not for me. You can just take the two leads and put them across, and it should beep at you. It's beeping at you, you know it's good. So you know your fuses are good. See?
Does that come? There's a battery in there.
This battery, yeah. It
Yeah.
lasts a long time. Is
I got a couple of those I can give you one. I got a real big one over there.
Yeah, that's
More complicated.
The one-
Yeah, you don't,
Don't
need
get
the
the big one.
No, it's $15.
The one on wheels?
Radio Shack.
No,
Go ahead and plug this
I
back
like
in.
that one.
it's so simple.
Okay, so if a customer were to change the supply, they would have to take this out if they were doing it like that. Just take it out, and we have another one just like it. Put it in. That's all.
So none of those things you have to
You
come
disconnect.
out.
Nope. This is our module, power supply module. So we'll go ahead and pop this back in. Laser's on the bottom. Longer in that direction. An X, that's a little bit different because it's a lot larger. If you look at the back of an X, there's going to be a box down here like this. That's where the CPU and power supply are going to be. That's it. So instead of them being here like this, we just kind of moved it there and there. It's the same thing.
So I could, if I had to, say I went on a job and I had to replace something in there, I could call up and say, hey, you know, maybe extra screws there, like I'm loosening up the panel instead of, you know, pulling out.
Yeah,
the screws.
you're saying, is there a chance of unscrewing something that you shouldn't be, or,
Right, like
or
that.
wrong? No, not really.
Uh-huh.
No, because once you see them, you'll look at it and say, oh, okay, I know
All
how
right,
this
these are
guy
the
goes
ones.
together.
Okay.
Exactly. So the X's are really the only ones that are a little bit different. The C's, actually everything's exposed on the C. You just lift the back cover and you
That's
see
easy.
everything right there. Power supply, CPU. But that's all there is in the backside of any of our machines, just the two units. Power supply, CPU, and laser. Three things, that's it. So the power supply is going back in now. We just put our 4 screws back in, we'll plug everything back together, and away we go. This is yours.
oh, he's gonna give us the broken one.
No, this is yours.
No, I'm teasing.
Really, because the only one has the memory sim in it.
The one from Yugoslavia.
No, I wouldn't give you that one. Okay, there's a little shelf here. See that? You got a bracket, and you got some tabs here. This slides in over there like that, see? Now you can pull the harness out and connect it out here, or you can kind of slide it in, then open up the cover and connect it while it's in there. You can do it either way. I like to kind of slide it in.
And that's where I have to have the laser tube out.
Yeah, open up the cover here. Then I can kind of, we have an option, air assist. There's 2 different types. There's just regular air assist, which we just run a couple of hoses through this thing and it blows air inside the machine. And then there's computer controlled air assist, where there are solenoids that turn the air off and on and all this kind of stuff. There's a box that goes right here. Okay? Now, unfortunately, that was an afterthought, computerized air assist control, and the box winds up being overhanging this area like this. So my point is, if you needed to take the CPU out, in order to get these 2 screws out, you got to take the box off on the air assist, because these are underneath it. That's all. So you could get these 2 out, but you can't get those 2 out. So the box would have 4 screws on it. You drop the box, and then you can get to these 2 screws. Because otherwise you take the 2 screws and why is this thing not coming out? There's 2 more screws in there.
Well, that's the thing I'm talking about.
Yeah, like with other models.
Like, yeah.
We use that air assist mostly for what? For cooling.
What is air assist? No, air assist is used, I mean for cooling what?
cutting.
Well, when you're cutting, is it for cooling so it doesn't light on fire, or
That's the reason. We
is there
use
also
air
different
assist.
chemicals you put in the air?
You can use nitrogen because it is inert, or CO2, just to prevent flaming. That's the whole concept of using air assist.
Anyone have soda?
Because there will be situations.
you.
What's that noise?
Electric light.
Oh.
there will be situations where the materials that you will be cutting or engraving tend to puff out flames here and there, especially stuff like rubber stamps. The power supply itself is not mounted to the body. The power supply module, that enclosure, is mounted to the back panel. It's not mounted to that. So, if you get the machine apart, you get the screws out here to get it off the stand, there's still wires that run down into the power supply, because the power supply is not physically connected to the body. It's bolted to the cart panel. But there's an electrical connection, so if you try lifting it up, you can yank the harness out and bust the thing. Right. So there's specific instructions in the X manual in section 2.
What do these things weigh anyway?
Altogether, a couple 100 pounds, 200. That you have to take off a little cover, and then you can see the connections, just like you see the connection here, and unplug it.
Yeah, it's very
And
easy
then it's
to do.
free.
Run them through whatever hole.
Yeah, just run them back through the hole, you can lift it out, and away you go.
Yeah, you want to go through that with them, and I do that. It's not really your responsibility, but if you're ever in a spot, because they might just disassemble the stand and yank the thing off,
Yeah.
and pull the thing right out.
I told them that at Harvard Scientific. I didn't know about that. It's a good thing they didn't do that.
Phone Vince real quick?
Yeah, go ahead.
Okay, so the last thing we can do here is just take the cover for the CPU. Here it is. Now the reason why you couldn't see the wires before is because the cover was covering the wire connections and everything. But since that's since A there, so you can run the files around, and also connects to the display board so you can see what's going on and push the buttons and everything. So the CPU does everything except have a power supply. So it needs power from the power supply, 48 volts DC, and then the CPU controls all the movement of everything and the firing of the laser. Because the laser doesn't work, doesn't necessarily mean that the laser's bad. It could be no signal coming from the CPU. However, that's never happened, but it is a possibility.
And you can check that by checking the voltage is getting to the laser tube.
Yeah. And we would walk you through that.
If the voltage is registering on the laser tube, that means the CPU is sending the signal there.
Right.
That's how you check it.
And
It's
you
real
can
easy.
send multiple jobs down.
Yeah, in our
Most of that
CPU
memory.
system, you can store up to 99 files, providing that you don't exceed the capacity of the memory set. Just as long as the files are not that big. So you can have like 4 really huge files in there, or you can have 99 little ones.
It's amazing how only 16 megs in there and you can handle all that.
Oh yeah,
It's 60 megs of compressed data, though.
yeah.
It's really
60
more
megs,
like...
Yeah.
Big
it's like
files are very
hundreds of
small.
megs.
So if one
See the
file had
filter?
a lot of
Yeah,
intricate
Gary.
designs in it and things like that,
I didn't want to show you that because you're a neat freak, and you're gonna clean everything. I saw her inspecting with a white glove over here, touching on the inside.
Oh, dirty bin. I didn't
not
know
that
there
bad.
was a filter there.
Now you do.
Yep. Clean it right
I'm
now.
sorry, what were you saying?
so if a file has a lot of motions in it, and that's what's
It's
gonna
not
make it
really
long.
motion. Not really motion, because see, if like that file that you showed with the vector, the paper cutout,
Right.
that's really not that
It's
big.
small.
It's a small file, maybe 200 kilobytes, 300 kilobytes at the most.
Uh-huh.
Where the files get big is in big raster files. Raster files take up more information than vector files do.
Like photographs.
Big photographs, pixel by pixel data. Rubber stamps where we have to create shoulders,
Right.
that takes up a lot of space.
Uh-huh.
So think of it as an area. The more area you take, raster fill, the more memory it takes. It also has to do with detail. Because if you have a big black box, for example, you just make a big black rectangle, you make it the size of the field, it's only a couple 100 kilobytes. Because the data is repetitive, it's just black on every line. So the compression kicks in and says, hey, if it's black on every line, I'll just duplicate that information and repeat it
How about the
10,000
DPI
times.
of it? Like if you scanned a
Yes.
black and white image in at 600 DPI when you don't really need to, it's going to slow. That's going to fill it up.
That's
too,
a
right?
good question. It's not the DPI that you scan it in, it's the DPI that you print it at what has to do with the file size. We have 6 different choices of DPI. 1,000, 500, 333, 250, and 200.
Otherwise
Higher
known
you
as
go.
654321.
Now it is called image density, but before it was called DPI.
Yeah.
So if you go to 1,000, you actually have 4 times as much information than you do at 500 because it's twice as large in the horizontal and twice as large in the vertical direction.
Doesn't matter even if your file would be scanned at 100 DPI and you set it at 1,000, it's still going to do that.
It will do it at what you set it at the driver. Okay. Okay, that's the back side. Yeah.
And also, one of those harnesses to the CPU is coming from the parallel port.
Yeah, one of those
One of
connectors,
those, and-
right, is this connection.
Right, and one came for power.
One for
There
power.
was 6.
Yeah, one's the serial port, one's the parallel port,
That's 2.
one's the power, one are the motors,
Step motors.
one is the display board,
Uh-huh.
and the other one is all the other sensors
Okay.
that are in there. The interlock
Homing
sensors, the
device.
beeper, the homing, all that kind of stuff. So
Okay.
there's your 6 connectors. Very good. Actually, if we looked at it here, I can show you that this is how they connect. You've got serial port, parallel port, power, motors, display board, and all the rest of the sensors. So they're all kind of isolated.
Right, uh-huh.
So if you forgot one, like this one, you didn't plug it in, none of the motors are going to work.
Right.
But everything else might work.
So if something is misbehaving, you might have to go back to...
Yeah, let's say,
something like
right.
that.
Let's say you did not have a power to just one motor all of a sudden, you know? And it's like, well, maybe when I push this thing in, I didn't get it in all the way. One of the wires is not touching.
Right, uh-huh.
But sometimes what has actually happened in the past, some of the pins have pushed out of the backside of the connector accidentally. So somebody pushes in the connector, but it wasn't in there all the way, so an individual pin might have popped out the back.
Uh-huh.
That's happened. It's rare, but it's happened
Trouble,
before.
yeah.
And you push it back in, click
Uh-huh.
it back in, plug it back in, and it works again. But it is possible. So that's it. Okay. Nothing else on the back side except the cart panel.
Oh man.
The reason why I showed you the back first, I just wanted to get that out of the way. It has nothing to do with regular maintenance or anything like that. I just wanted to talk to you about the components, show you how to take them in and out. That's pretty much it. As far as what you do for regular maintenance, as far as the customer is concerned, and what they should know on what to do is how to clean it and maintain it. And in the book, you have the manual?
There's a whole bunch of them.
Oh, yeah, they're right there.
Anyone you want.
Look a lot more professional. Okay. Listen, I wrote the manual, so if you find any spelling errors, I don't care. No, I'm just kidding.
And if you don't like it,
Too bad.
If you don't like it, I'll take the laser.
That's because Word didn't catch it, because this was spell checked in Word, and it didn't find a lot of stuff. Okay. Here's the maintenance section. Now, I love my first sentence. Clean machine's a happy machine. Well, it doesn't say that, but that's what I mean. Keeping the system clean will ensure the highest quality engraving and the best performance. Now we have some suggested cleaning and maintenance supplies. Soap solution and a tablespoon of liquid soap. General all-purpose cleaner. Just get a spray bottle with some dishwashing detergent, Joy or something like that. Put a little squirt in the bottle, fill it up with water, shake it up, and now you have your cleaning solution. It's non-abrasive, it's just soap and water. Great, works on everything. Okay? Now you're going to run into situations where soap and water is not going to be able to clean off stuff. So you're going to get some plastic residue on the table or different things, maybe even some wood residue that you're not going to be able to get off. We have 2 other things. Denatured alcohol and acetone. And we'll use those for 2 different things. But we won't use these things on the moving parts. We'll use that pretty much on the table only. You should just really use soap and water solution on all the motion system components. Okay, and we'll talk about the individual components separately. Paper towels, you can use that or a cotton cloth. You need something to wipe it down with. We give you cotton swabs, lens cleaner, some lens tissue. Vacuum cleaner would be nice to have because a lot of people cut out small pieces like that guy cutting that paper. I bet you he's got little pieces of paper everywhere. And they will get everywhere and they will cause major problems. So have a vacuum cleaner to suck all the little pieces out. And a set of Allen wrenches. Because everything you've seen right now, we've been using Allen wrenches to take things apart. This little kit that I have, I can practically build a machine with this little bag and a set of Allen wrenches. Okay. Yeah, I put notes here. If you're using these chemicals, always follow safe handling procedures. And the next page here is a map, sort of the motion system and all the different components. Now, the reason why that's there is obviously the words are referencing this picture, but we also use this picture to reference parts, because if you need a part and you don't really know the name of it, 95% of the parts that we ever order for maintenance purpose or replacement are in the motion system. Obviously there's things like a laser tube, CPU, and power supply, but it's rare. But the stuff that does wear out is up over here. Now you can see the whole motion system here. The primary stuff that wears out the most is the stuff on the focus carriage and whatever has to do with the X and right movement. So let's look at it here, and let's just verbally describe the parts, but you can use this as your future reference. Let's take a look here. We call this our focus carriage because it contains the focus lens and the number 3 mirror. We have 3 x-axis bearings because this direction, left and right, is x-axis, this direction is the y-axis, and the table moving up and down is the z-axis. X, Y, Z. Okay? I'm going to take this... Yeah, I'm going to take this cover off over here by taking out the thumb screw, and this cover just slides to the right and up and off the system. Just put that to the side. It's just a protective cover to kind of keep some dust out of there. This is the beam window. The beam exits through this optic, hits the number 2 mirror, because the number 1's mounted on the end of the laser tube. Number 1's in there, which you never clean. Goes through the beam window, and the beam window only gets dirty on the outside, doesn't get dirty on the backside. Very rarely would it get dirty on the backside. So if people cleaned it, you clean it right on there. You don't take it out to clean it. We'll go ahead and do that. Beam window, number 2 mirror, number 3 mirror pointed on a 45-degree angle, and the focus lens going through the bottom. Okay? Focus carriage, 3 x-axis bearings, 2 on the top and 1 on the bottom, because there is a V-groove on the top and a V-groove on the bottom, like this. X-axis belt, X-axis idler pulley. The reason why we call it an idler pulley is it's an automotive name, actually. It's for a pulley that doesn't have any teeth on it. It's just a piece of plastic, and if you looked at the pulley, there are no teeth to grab the tooth belt. Because if you look at the belt has teeth on the inside. But in order to drive the teeth, you need a drive gear, not an idler pulley. That's an idler pulley, and the drive gear is on this side, connected to the x-axis motor, because the x-axis motor is underneath this plate. So the motor has a gear, and it turns, pulls the belt back and forth, which moves the motion system focus carriage, turning the bearings, etc. Okay? We have 4 y-axis bearings. We have 2 y-axis bearings on this side and 2 y-axis bearings on this side. And these are called the y-rails. This is the x-rail or the x-axis arm. We call it 2 different things. It's this whole arm, actually, this whole rail system will come out with 4 screws. If somebody seriously damages this arm, let's say they take a brick and they drop it here and they bend the arm or something like that, we can swap out this entire arm by just removing 4 screws. We'll show you how to do that. We're going to take this whole thing apart and put it back together.
You wouldn't cover that under warranty, though. If they...
No, we don't cover things from abuse. But there will be a point where somebody will damage this either through chemical abrasion or improper cleaning or abrasive particles that they're engraving, and we'll eventually have to replace this arm. And the beauty about it is this arm is the quality that you produce. And you can get absolutely brand new laser quality as if you just bought the machine if you have damaged the arm by replacing the arm. If a customer
how
ever
strong
had
is
to
that?
do it.
Can someone wreck it from leaning on it?
No.
Not really.
Like you put your weight on it, something like that, no. It's very strong, to tell you the truth. If they drop something on it,
Yeah.
I've stood on this thing and you
Really?
can't bend it.
Stood on it?
Yeah, I've stood on it. It's
Let me try
extrusion. No, that's a different story.
Uh-oh.
And you
No.
need a new arm.
Actually, the table's very strong too.
That's the honeycomb
The
table.
honeycomb table, right? People always say, well, how much weight can the table hold? I say, well, you're going to have a harder time putting wherever is that heavy in the machine than what the table can hold. Because if you try to take a 200-pound block of granite, I don't think you're strong enough to lift it over the top. You know what I'm saying? I said, believe me, the table's strong enough. I've stood on the table and took pictures and everything and didn't break it. You can't lift my weight. Lifting is different than holding. We can hold 200 pounds, no problem, but we can't lift it. We have a motor and gear and CPU power to the motor that will only let us lift 40 pounds for safety
Probably not
reasons.
even wise to lower it with that kind of weight, is it? I guess you have no choice. You got to lower it.
You could lower it. If you were going to do something very heavy, the whole idea would be is figure out the focal height of what it is, and go ahead and program that focal height into the system so that when you put it in there, it will automatically be focused, so you don't have to move the table. And we'll show you how to do that later. But the table's very strong. Not too worried about that. So anyways, let's get back to the motion system. Oh, you still got your rubber band in here. don't want to lose
I
that 'cause
keep
you
that.
tie it down. I know.
Yeah,
I know.
that's not the original.
Alright.
I stick it there.
Okay. Y-axis belts. It's made out of the same material as the X-axis belt is. If you look underneath here, you got the Y-axis motor, 2 Y shafts going out to the Y drive gears. Okay. And by this motor rotating, it brings the arm forward and backwards. Y-axis, see it's a little generator. Look at the lights go on. Display board. Y-axis idler pulleys, 2 of them. 1, 2. Y-axis home flag. It's not the sensor, it's a flag. The sensors are here. And we'll take that apart and show you that when we take this assembly apart. When we turn the machine on, what it will do is as it's powering up, it'll move back into this corner and over to the right, touching this button right here and passing the flag through a sensor, optical sensor right here,
Like a U.
shaped like a fork, a U. Okay? Now they're optical sensors. This may look mechanical, but it's truly optical because it's actually going through another U-shaped sensor inside that you can't
What's
see.
U?
Like upside down U.
A U.
What is
The
that?
letter U. The sensor that's in there.
You'll see when we take it apart.
Yeah, I'll show you when I take it apart. But here, the concept is this. We turn the machine on, the fans come on, it beeps at you, you get M300 initializing, the lights are starting to come on, the little clock is starting to tick, these little bars are expanding. It's going to get power to the motors now. Now it's stiff. In a few seconds it pulls down to in, out, back in, out, back in. Because it checks itself twice. It goes in and out and in. Okay? That's the homing procedure. Every time you turn the machine on, it's homing. That's the only way it knows where its starting point is. Now the Z doesn't home. We try to save some time because usually people want to just power this thing up and get going. And the older systems like the PSs and Es, the older models, not the Es, but the PS models, the table would have to home all the way down at the bottom, move slowly, and then move all the way back up. It was just becoming an inconvenience. So we added the battery to remember where its Z position was. So when you turn it off and turn it back on, it didn't have to home the Z. But we always have to home the X and Y axis because it's not backed up. And homing is very important because the way the system is designed, the motors don't know where they are. So if I accidentally did that to the system, it still thinks it's over here. The CPU doesn't move that I mechanically moved this thing. So it'll cause big problems because everything I place on the screen will be displaced by the amount of movement there.
Plus it'll be banging in
It'll
the
be
end.
banging on the end, right.
6 inches further.
Yeah.
Can I hurt it? Banging on the end?
It can, yes. It can damage the bearings. But people have done this from either mechanical interference or accidentally hitting it or something like that. Same thing with the Y-axis. Okay? Did it give you a chill? Feel it kind of go up your spine? Ooh, I heard that noise. That doesn't damage the machine necessarily, but everything is off now. Now you can get it to re-home by turning the machine off and turning it back on, but you can do it on the front panel also. It's the same concept. And we can re-home the X and Y. We'll show you how to do this. Oops. We'll show you how to officially do that later. Just to show you that it does work. Because what will happen is, if you have files in here and you accidentally bump the carriage and you turn it off and turn it back on, your files will get erased. That's not what you necessarily want to do. You just want to re-home the X and Y. You can do it through the control panel. But again, there's no feedback. These are stepper motors, not servo motors. There are no encoders or anything like that. An encoder tells it where it's at. There's no sensors to tell it where it's at. So when it goes from here to there, because you drew it up on the screen to engrave here, stepper motors are given a signal. It tells it how many steps to take, how far to travel, and start engraving. If it's mechanically offset, it has no idea. Okay? Okay, so that's the homing procedure. You can see the red light flashing. That's because the top door is open. As soon as we lift up on the door, the red light starts to flash, telling you that the interlocks have been triggered. The laser beam will not fire. However, the red light will fire, because as you can see, the red light stays on regardless of whether I open and close the door.
I did that with my friend. They said, no, your finger.
Oh yeah, you got it, huh? Okay, now when we initially install a laser tube, when you first put the machine together and you pop the laser tube in there, here is a procedure in the manual showing you how to check it to make sure that it didn't get bumped around too bad, etc. So what you do is take a piece of masking tape like this, and you turn the machine on and you let it home, and you take the tape and put it right over this hole where the beam is going, and you look to see if that red dot, make a little impression with your finger. Look to see if that red dot's in the center of the hole. Now, take a look. It's really not in the center. Not even close. You see?
Yeah.
You're right.
It's way down to the
Yeah.
lower left side. Now that could mean that we put the laser in wrong. So what I suggest that you do if this were to happen, if this were to happen, it's okay, leave it there, is to reinstall the laser tube. Take your stuff off, open the cover, and just lift it up. You can do it while it's on. And see if it's in the same spot. Look, it still keeps going back to the same spot. So it's nothing binding or anything here. We've got a weird problem going on. Now we have to investigate why. Now what we tell people to do, if there's no rep involved, they're doing their own installation, they're putting this together. I tell them, if this is off center, don't do anything, call the service department. Because we want to walk them through, seeing where the problem is. We don't want them just ripping stuff apart and seeing what's going on. But obviously in your case, if you're doing it, you check this yourself, and you make adjustments that are necessary. Okay?
Do you know what the problem is?
That's it. That's what we're going to find out.
No, I thought you did that on purpose. It's like just a detail.
Maybe. Maybe not. I will never tell you.
It's good though that this happened.
Yeah, no, we have to.
This is gonna be one.
I will sabotage stuff and not tell you. Okay, the first thing we're going to have to check, sometimes it happens in shipping, is that this arm becomes what we call unsquare. Okay, it gets dislodged somehow because it got dropped really hard in the machine or something. Now how you check its squareness is you take that cover off like I showed you, and you pull the arm all the way forward. Now there are two pins. There's a pin right here. You're going to poke your head over the side and see that pin there. And there's one over here. See? They're shoulder screws. Okay? Now the shoulder screws are just stopping blocks.
Yeah.
They just stop. So,
They should both hit.
both sides, this side and that side, should hit the screw at the same time. There shouldn't be any gap. Is it hitting there?
Yes.
It's touching? Yep.
No, actually, no.
No, it's not?
You got to hold one side and tap the other.
Let me put on my glasses. And I'll see.
Okay, it is touching.
Excuse me, Larry.
Looks like it's touching.
Yeah, just got to hold this and then tap.
That's true, if that side was off.
Yeah, let me see. No, it's touching.
Okay, let me check this side. Now, that side's not touching. See that?
Right.
See there's a gap there?
See, yep.
Look, see, he's pulling on it. See it move?
Yeah.
It's not touching.
Did you do that? Did you sabotage it?
Maybe. It's besides the point. It's not touching, so we have to fix that.
That's what I said before.
So let's fix it.
Maybe because the hole is not the red thing is not exactly.
Oh, the fix is real easy.
Okay, you're gonna like this.
Yeah, it's easy. This is especially critical with architectural models. But
Oh yeah, big time.
you have to go through this procedure when you install it with them.
Why?
If you look over here,
It has to be absolutely perfect for them. Straight.
here is a coupler, and here's another coupler. There's two screws on each coupler. 1, 2, rotate this a little bit. 3, 4, okay? These are called flexible couplers. They're like CV joints in a car.
Same with the great helical couplers, right?
Yes, exactly. Now, what we do is we pull the arm forward as far as we can go, and just loosen one of those 4 screws, whichever one you got access to. Just pick one, doesn't matter. loosen it up. Get your Allen in there, loosen it. Once you loosen one screw, both sides become independent. Look at this thing, look. See how it moves? One screw. Pull it forward so that you're actually against both pins and tighten the screw back up. That's it. As far as it, now they're both touching at the same time. However, there's one other thing that you have to do. Once you've done that, you've tightened the screw, push it back into the middle of the field. Loosen this screw right here and this screw. Because if you look at this, you can see this pivots on this center shoulder screw. That keeps both bearings riding in the groove properly. By loosening the screws, there's a spring that pull over here pulls this whole arm in. See it?
Self-adjusted.
It self-adjusts the two bearings and they're both in the groove and you tighten it up.
That's after you did
After you square it, right. So the answer is, to recap, if it's, you check, see if it's touching here and touching there. If it's not, you unscrew one of the screws. It's still a little bit off, so I didn't do it right the first time. So let's loosen one of the screws, pull it back in again, tighten the screw, push it back out to the center, loosen both.
Wait, but why do you want to loosen those again?
You want to so that, because if these are on an angle, a slight angle, like this or like this, then what will happen is the arm will rock in this direction. You'll get bad vectors. Just let it, you don't have to push on it. You just loosen the screws and tighten them back up. So the answer is,
service call problems.
this is a typical problem, yes.
No, usually what I do, I don't know if this is right or wrong, but it's when I loosen those screws up, I bring it to the forward again and then tighten them in that position. To make sure it's square.
I would think to do that first before I do this.
No, you can't do that first,
No, that has to be second.
because this is subject to that.
Right.
So
Now,
what you do is you bring it forward,
bring it forward.
make sure it's
You're pulling it in.
right. You're pulling it in the kind of in the middle.
Loosen the
Take it.
screw.
Well, yeah, loosen it first.
Yeah, right. Loosen it
All right,
first.
and then once
Pull
she's
it
tight
in.
like that, tighten her up again. Bring her over here.
Yeah.
Loosen. All right, make sure they're in, and then you tighten them up again.
Yeah.
Do you bring it back, tighten it up, or
Yeah.
tighten
No,
up
leave it in the
anywhere?
middle.
Leave it in the middle.
Leave it in the middle, and when you do this, again, just loosen one quarter turn, loosen the other. That's it.
all it takes.
It'll do it by itself from
Yeah.
the spring, and then just tighten it back up. But make sure you loosen both of
All
them.
right, to like reset them,
Yeah, that's what resets them into place, because the spring's going to pull it in automatically.
and nothing on this side.
Nope, because this side actually is the spring-loaded side. It automatically self-adjusts.
Uh-huh.
That side isn't. It's fixed.
Uh-huh.
We can't have all four.
Is that also
Self-adjust.
the way to take this arm off?
Oh,
No.
we'll show you that later.
Okay, good. All right, I just
That is just a squaring adjustment. And this happens sometimes just in initial shipping. The thing gets bounced around so hard, it bangs all over the place, that it's going to knock the arm out of square. So this sort of thing, when you go to set it up, you check for square. You pull it in.
so
you-
on an installation,
Yeah,
that's one of the things
absolutely.
that I check.
That's the first thing I checked,
Right.
if I remember when I was there.
First
Yeah.
thing is remove the things here and clip the.
Right.
Yeah, there's going to be a tie down. There's going to be
I used to do that. Turn it on.
Don't turn the
Oh
machine
my
on.
gosh!
Okay, now that could have been one cause of the beam not being sent.
That could have been.
One cause.
Sure.
okay.
Sure. Okay. Once we're square on both sides, now we're going to go back and recheck that beam alignment. Okay. But before we go and do the beam alignment, what I suggest that you do is you take out the lens and the mirror. And the reason why I suggest that you do that is because we're going to actually burn this tape with the beam itself to see where it is. And we don't want the smoke getting on the optics, because then we got to clean it.
So you only really need the laser to go that far.
Yes, we only need the laser to go that far. We don't need it to turn down. So we're going to take that out. There's your number 3 mirror and your focus lens. And we're going to put that in a place where we're not going to drop it or anything.
Yeah, hold it.
It's
Actually,
okay, I got an extra one.
I
got two
clean,
extras.
I didn't clean the laser because I knew you were going to come and show
Oh,
us how to
likely
clean it.
excuse.
But then will you burn the metal?
No, you won't. Good question, no. Good question. No, the laser's not strong enough to burn metal. So it's going to hit it and just kind of stop. Plus, we're not going to put that much power on it. We're just going to use enough to burn the tape and not really, like, cut a cord or anything. So we put the tape over the hole, and make sure you got it, put it in there nice, you know? Get it nice and tight so you can, and run your
you see
finger
it
around
right
the
now?
outline. Yeah, I can see. Run your finger along the outline of the hole like that, so you can see where the edge of the hole is. Okay. So go ahead and turn. We'll go ahead and turn it on. It's going to home and everything like it does. I'm going to clean this display board here. It's all dirty in there. We'll show you how to clean that. Now it shouldn't be happening on the newer models because we have a little gasket that we put in them. Okay, now we don't need the computer to fire the laser in what we call alignment mode. To be totally disconnected from the parallel port. All we've got to do is be able to turn it on. Put our piece of tape in there, and what we'll have to do is we're going to have to close the door here.
You don't want it down here?
Not yet. Not at this point. We'll go down here later, but we're just going to leave it in the natural home position for right now.
Why isn't the red beam?
Because I didn't turn it on. It won't just come on unless you hit the XY button. Hit the XY button, you can see the red beam. Now we're looking at it, you can see it's still in the same spot. It didn't move. So there's something else wrong here. We have a thing called alignment mode. We escape out of this menu, go down to Preferences, select, go to Diagnostics. We've got alignment mode here. We go into alignment mode. You got power 3%, kilohertz 2%. Now we start the power at very low because in this mode we're only expecting you to burn tape. We're not expecting you to cut acrylic. So we're not going to put like 100% power there because it'll catch it on fire really easily. So we want a small amount of power because we just want it to turn brown. We don't want to blow through it. So 3% power, it might be enough, it might not be enough. We might have to bump it up to 4 or 5% or 6%. We'll see what happens. So let's close the door. Now, the green light is on. That means it's going to fire the beam. Now we look at that, all right? And what we do is we take our finger and we put it on the XY button. And in order to fire the beam, we push it once and let it go, and it's going to be firing constantly. And the beeper is going to beep at you, beep, telling you that it's firing because you can't see it. Hopefully, it'll start burning that tape very slowly. And then to shut it off, we push the button again. Once on, once off. Wax on, wax off. Right, kid. Here we go. So I'm going to watch it at the same time. Here we go. On, off. See? There's our spot. Cool, huh? That's the size of the beam at that point. Now, if we look at that spot and open up the door and put our light on there, I like to shine a light in the backside. You can see the outline of the hole maybe better. Is it in the center?
No.
No, huh?
No, it's pretty close.
It's pretty close. It's not good.
That's close enough for me.
There you go. See? It's close enough for him.
I'm in. That's it. Beam aligned.
Beam alignment's done.
Is that good enough for the architectural model?
The thing
Very
is,
good. Let's what?
But look,
What?
the tape's a little on the bottom. There's a hole there on the bottom. So you can't really have it exact.
That's good enough, John.
Okay.
Is
But
good enough for a Lenin model?
it's-
Yes. That's good enough.
Because you're very
it's good
particular.
enough. But
though,
let's
for-
pretend it's not good enough. All right, but let's see where the red dot is first. Let's go out of the menu, escape out, go back in, and the red dot will come on. Ah, it's a little off, isn't it?
Yeah, it is.
And open that little cover.
Very good. That's it.
What is it?
We're going to take that little cover off and we're going to move the red dot. Now, since both beams are coming out of two different places, if the red dot is off from the
Wait, where's it? No, it's not.
Let's want to know if it's jacked.
It's in the middle on
No,
this
it's not
mirror,
jacked.
though. It's in the middle of that one.
that's good.
So that means it's like
Harder to tell it's so close there, though, right?
It's good. He's a pro. You know, you've been conning me this whole time. He knows what he's doing. That's good observation. Glad you saw that. You can see it's coming out of the middle there. And it kind of looks like it's hitting the middle of that mirror, but it's kind of off over here. So what you're saying is that we got a little problem from here to here. Maybe that's not aligned right. You're almost 100% correct. But there's two problems here. The problem is that the red dot is off from the burn, as well as the burn and the red dot are not in the center of the hole. Just for fun, so I can explain how to do this, we're going to make the red dot go on top of the burn dot. And we're going to adjust the laser to do this. But once we get that dot on top of the other dot, that doesn't mean that the dot is in the center of the hole. To adjust the dots, combined dots, to the center of the hole, we would adjust that mirror. That's our only adjustment that we have. don't have anything else to
With the
hook it
laser
to.
beam itself.
Yeah. When we adjust this mirror, we're adjusting both the red dot and the burn dot at the same time because they're both hitting the mirror at the same point. Right now they're not hitting it at the same point. We're just going to monkey
So
with the
if you
laser.
adjusted to get the brown in the middle, the red's still going to be on top.
Well, what's going to happen is if we went right now and adjusted this mirror to get the red dot in the center, the brown's going to move the same distance away. So the brown's going to be up in the corner then, if we adjust the red to go to the middle. So let's go ahead and I'm going to take this cover off. Now, granted, I would kind of just leave that alone.
Me too.
As far as the red dot is concerned. But I'm showing you this in case it was extreme.
Do they allow you to bypass these like they used to in the old days?
No. No, but you could if you just threw a couple magnets on it. But we actually took out, the rules changed for laser safety, and they didn't like us anymore putting in the interlock defeat tools. So we had to get FDA. I took the cover off. Inside the cover you see 3 screws. 1, 2, 3. Those are angle adjustment screws. You can't miss them. Only 3 screws you can see. You take your tool, Allen, and you put on one of them. Just pick one. I don't know which one. Just turn it and see which way it moves. If I turn this to the right and say, oh, look at that. Cool, it's like Etch-a-Sketch. And go up and down with this one. So we need a little go up, like that. And now I pick another one and see if I can move it to the side. Oh, look at that. There we go. Am I there?
No,
No, I gotta go a little
to the right.
to the right, and maybe a little up, huh?
Why do you put the line in that?
Maybe a little down.
Down and to the right.
Close enough. Close enough. Anyways, I'm gonna mess it up again. Okay, here you go. Okay, stick it in there on that screw. Pick one and turn it. Okay. Take an old 50 Allen wrench, a little sucker. We come over here. Now, we have 3 screws. 1, 2, 3. This one right here, you don't touch. Okay? It's only these 2. The ones that are diagonal.
Don't touch the middle one, it's a pivot screw.
Right. That one has a spring behind it. You don't turn that. It's a lot harder to turn, too.
Which one do you
What
want?
happens if you do?
One in the middle.
Well, not that it doesn't do you any good
That one?
because it messes your alignment up. This is your left and right adjustment. This is your up and down. You don't have to remember that because all you gotta do is turn it and see which way it goes. So I'm gonna take the tool, stick it in there. The little tiny screws. There we go. Get it in there real good.
Look at the red dot on there. Move.
Watch the dot and look. See? Move it up and down.
Can you see that, Larry?
Yeah.
It's moving on the tape.
There.
Watching the reverse side of it.
Yeah, you can see right through the back. Up and down. Left and right. Get it kind of centered there. Okay? Close
Now
enough.
you can feel confident because we lined the red thing that they're actually
The CO2 is going to be there too.
CO2 is going to be the same.
Take it, close the door.
That's why you did that.
See? So that's in the middle too. It's not, huh? What do you think? You think so?
Get down a little bit.
So cool, like the smoke.
Think so? It's over to the right, maybe?
Yeah, over to the right.
Yeah.
Okay. Okay.
Fraction.
I tell you what. There you go. Knock yourself out.
Do you remember which one is
Yeah,
which?
this is left and right. That's up and down.
That's right.
Make sure it's in there. Let me put my glasses on. I had laser surgery on
Did
my
you?
eyes. Yeah.
Yeah, there you see.
Fire?
Did you
Why?
do
Why do you
this?
just stick your eye in?
Did it not work?
Oh, it worked
Did you do
perfect.
it?
I can see
What?
beautiful
Laser
fog.
surgery.
For reading,
Oh,
it doesn't
for
work.
It makes it worse for
Kevin, I told you you shouldn't have stuck your head in this laser.
Should have trusted Vince to do it.
Right.
Enough about tattoos, guys. That was a good thing.
If I hear one more tattoo joke about lasers, I'll kill myself on an installation.
How about branding cows?
The other way, there you go.
Field. Now let's see. That was not bad. Maybe a little low.
Yeah, I would say that's good enough.
I know.
Close enough.
But what do you think? Does it look a
pretty
little
good.
low?
No, to me it looks good.
No, it looks good to me.
Okay, great. I'm glad it would be. It's supposed to be. Okay, that's beam alignments.
With this new lasers, with the old lasers, you have to do the...
First, because we're going to take this thing apart and put it back together, and we'll have to realign it. But I wanted to show you that because upon initial installation on a new machine, obviously you're not going to take them apart. You're going to throw the laser in, you're going to make sure it's square, you're going to check this, and if it's slightly off, just tweak that mirror a little bit, get it centered, and away you go. Now, hopefully the diode's not off from the burn either, and that'll be okay. If you want to tweak it, you can. It just makes it more helpful for you to see where it's going to show up as far as the center of the field. Because without the diode, and you start turning that thing, you don't really know where you're going.
Pointed that way.
Yeah, exactly.
Oh, okay.
And this is the main menu.
Right.
When you first turn it on, you'll get ready.
Okay.
If you press escape out of that, go down to preferences,
And
select.
diagnostics.
Go to diagnostics, select. There's alignment mode, select. And that turns on the red light, see?
Okay.
Then you can adjust it.
And now how am I going to move that around with these?
Yeah, hit a button. It goes to the corners. Hit the other button. Hit another one. It shoots over there. Shoots over there. Shoots over there. See? 4 corners. Now when you're ready to fire the beam, once on, once off. Now it didn't fire because the door's
Right,
open.
okay. And it won't remember that you hit the button.
No.
You know, like when you close it.
Oh yeah, it actually, watch. Watch what'll happen. So be careful. If you fire it, okay, it's not going to fire. You have to hit it again. Maybe some paper towels we've got and some cleaner.
Somewhere behind it.
Okay.
When you say cleaner, you mean Windex or just...
Yeah, Windex is fine.
What's that blue bottle?
Do you want me to remove the honeycomb thing?
No.
No, we're going to just leave it in there. Okay, basic maintenance.
Okay, shh, guys.
We already identified the parts, right? All the bearings, all the surfaces, and it's going to tell you, clean this, clean that. You should read it at your convenience. What you do is you spray the cloth. Don't spray in the machine. You never want to do that. Because if you do that, then what will happen is you might get it on areas where you're not supposed to, etc. You want to saturate your cloth, and the most highly grimed area will be the bearing surfaces. So you do this with the machine off. You can unplug it if you want to. That's no big deal. You clean the groove. Okay? And you can see the dirt coming off. Oh, what a filthy machine. I can't believe Julie let this
Julie's
happen.
grinning right now.
You know, terrible.
I've been on vacation.
Like
It got dirty by itself? Is that what you're telling me? That's what customers say. I never use it. How'd it get filthy? Okay.
Vincent, you're so blessed.
All right. So we cleaned the top, right? We already did that. Make sure you clean the whole entire length. Don't forget the little corners. Once you get that, take the wet part and pin it up against the bearing itself and roll it back and forth. Look at that stuff getting off of there. Look at that. That'll affect your engraving quality, believe it or not. That little bit of dirt, because every time it hits that little dirt bump, it'll vibrate the carriage, and it can make wavy lines.
Slow it off.
And great. It's
You
slower,
imagine
fast
some
speeds.
customers are just total mess, huh?
I'm curious
yeah.
as to why you prefer this kind of stuff instead of alcohol, which would do, I think, a better job, don't you think?
Yeah, because most of the stuff is wood resins, and water cleans wood perfectly. You can use alcohol. It's fine. I tell you can. But since I'm cleaning most of the system just with the
Soap
Windex
water.
or soap and water, I don't have to worry about getting alcohol.
Oh, burning-wise,
But
right.
that leaves a residue, though. Nobody's also that.
And another thing, you never want to saturate your bearings with fluid because then it will degrease it. Even though they are sealed, they're not really sealed fluid-wise, and fluids can get in there and dry up your bearings. So never spray into it. Now we've got a big problem here with this focus carriage because I'm looking at it and I see that there's something wrong. And what's wrong is the bearings are on wrong on this system. The whole carriage is on an angle. Do you see the problem, Vincenzo?
Hold on. Let me see something.
Now it's on an angle.
Yeah.
Do I see the problem?
Yeah, look, come look at it from the top. Look, stand right here. Look straight down and tell me what's wrong with this picture.
I just got fired by Vince.
That's probably
So
why
much for that
that's probably
factory
why our beam was out of
certification.
alignment.
This is true.
Yeah.
But I got to tell you something. I've been doing demos for a year, and everybody says they love it.
Okay, well we'll fix that. Not right now.
You've been selling the machines. I guess it's
Yeah,
okay.
that's funny.
So you gotta watch what these customers do because they'll do stuff like this and it'll mess you up.
That's stupid. That's the point.
Dog
The
on.
inside of the belt.
You could do the inside too, but you're gonna have a harder
I mean, not
time.
necessarily the belt, but I mean the track and the inside, or does it go
Yeah,
all the way
the
through?
cute.
It goes on the through on the inside.
Oh,
So I like if it's dirty. You can get in there. I take a toothbrush, you know, if it's really messed up. I'm just going to visually look at it. It's fine. It's clean. But if it wasn't, I'd take a toothbrush and get in there and get all the junk out of the middle of the teeth. Okay.
Because it could, if it loaded up, could skip over that.
It could skip over that. Right. Exactly. I'm just getting there
But like I
behind the
said,
belt.
if you're just doing for demos and stuff, then it won't be as dirty as a guy.
She doesn't have.
You should.
But notice how he pulled it to one side, cleaned the belt, and then
Don't
put it to
forget
the other side.
Yep.
Because then that means the other part of the belt's in the back.
What if some people are cleaning it at snaps? and it
Well, that would
snaps?
be bad. No, it shouldn't snap.
so what? A
That's really
bearing
strong.
went on you. That's why you.
Yeah, I changed those bearings. You go through a set of bearings once a year.
Yeah.
Okay, I'm getting it all.
That is so funny, though.
Look at that stuff. Woo.
Yummy.
Good
Ooh,
dirt.
ah.
You could like make icing with it. Okay, now I got to get the bottom part too. I did the top groove, but you can't forget the bottom.
That's the real dirty.
That's the one that gets dirtiest most. I kind of hit it a little bit before, but I'm going back and re-cleaning it up here.
Especially on that side,
Yeah, this side gets better.
because that's where
Did they
it's
used
Why
to have
that side? Don't they
the
do
home
almost
position in the upper left corner?
No,
No.
we never did.
always upper right. Home machine home is upper right, and home is upper left.
0-0. Right.
Yeah,
I'm rolling it back and forth to get the outside of the bearing. Okay?
That's where all the engravings be.
Yeah, right here. All
So
this
the
side.
lines
More dirty here.
Yes.
All right, we're doing good. We're getting this thing clean. Almost done.
Messy.
And eventually we'll straighten out that bearing. So we gotta take the arm apart. Then we gotta realign it. You can actually see that if you saw the surface of the bearings. The bearings themselves are composed of two parts. You have the ball bearings, which is the silver part on the inside, and then you have the outer race, which is made out of polycarbonate. It's actually plastic. Okay? It's Lexan. And it's machined. These are machined. These aren't plastic molded or anything like that. They're done on a lathe. That's why they're not cheap. And they're glass-filled polycarbonate. So what'll happen is, after a while, when it starts to wear out, it might wear out in chunks. If you looked at them closely, you might see little chips and stuff missing. It would be like a mirror chipping, you know? And it would get real bumpy as you're moving it back and forth. You'll feel the lumps going blah, 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 and grinding. But you'd be able to see that. Here you don't see it because it's nice and smooth in the wear spots. Now because it's a V-shaped groove, you're going to see the wear spots on the edges, not on the top. Okay? So you get it rounded like this, you're going to see them over here, like on the sides of your head.
That's where the grip happens on the sides.
That's where it grabs it because it's V. It's a V groove, okay? But these bearings are in great shape and they're almost a year old and they're still doing good. Except they
So when I'm saying you the bearings,
You tell.
bearings come with the roller.
We're going to take it apart and we'll show you.
So I mean, when you buy one,
It's all assembled, the whole
Oh, okay.
assemble and everything, the whole assembly. Okay, we finished cleaning it, okay?
Aren't there some of them that have the Allen key to take them apart? Another one had the wrench. You know, this part.
Let's clean the rest of it. So we clean the X-axis rail, we clean the X-axis belt and bearings. Let's clean any residue that we may find anywhere. They're all nice and shiny. And we're going to clean the Y-axis now. So we're going to take our cloth, find a clean spot, get it wet again, and same thing on the left and right sides. We'll go in here, clean off the rails, clean off the grooves, the most important part, on the left side. Pin it up against your bearing, roll your bearing back and forth, get that stuff off there, bearing back and forth like so. in there. We're doing good. Now the Y rails don't get as dirty as the X because the Y's are kind of out of the way, so cleaning that is not as frequent as the X axis. Okay, I think this one's done. Let's grab another one. And now we'll clean the right side. Now you got to be real careful about the right side. The left side's not so bad because you got the two bearings here. It's kind of wide open. I run my finger along the groove too in case I feel any lumps or any sorts of chunky things sticking out. It's got a little ding in the rail, but luckily that little ding right there is not in the track area and it won't affect the bearing.
Otherwise, that would make the bearings wear out prematurely. Then.
Could, absolutely. And it also could cause an imperfection right at that spot as it's traversing over it. Okay, now be careful about the right side because up at the top you have that sensor there. So I'm going to start at the bottom, get this cleaned off, run it through the V-groove over here on this side, pin it up against the bearing, go back and forth this way. Okay, and over here is where I got to be careful. Don't bend that flag. People have accidentally bent it over, you know, because it's kind of flimsy. Now we beefed that up on the newer model, so it's a bit stronger. But if you bend this flag too much and you turn it on, it can hit the plastic sensor and snap it off, and then it won't home right anymore. People have done this quite often. Be careful of this cable too.
What is that for?
This sends this is the wire that connects the motor and the sensors to the CPU. So we got that all cleaned up, ready to go. Make sure it's traversing really well. Make sure I get that. Don't forget that bearing that's over there. The other Y-axis bearing. It should feel nice and smooth. You move it back and forth. You feel for any lumps. Usually, if you're moving along, all of a sudden you feel lump, 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 lump. Something stuck on the end of the bearing. It's just cycling. If you just move it along, all of a sudden you get just one lump. Some location, something's on the rail. If you get continuous lumps, something's on the bearing.
And that's the same when you engrave. If
Yeah.
you see like a
Repetitive pattern.
repetitive pat, that's every time it's like a flat tire.
Yep. Wop, wop, wop.
Easy on the Italian stuff there. You're in New York now, Vince. None of that wop stuff. Of course, Larry McLaughlin likes that.
Yeah, yeah. All right. Okay, we're done cleaning the motion system. That's it. The contact areas are the rails and the bearings, surfaces, stuff like that. Tells you to do that. Okay, make sure it feels nice and smooth, and we can move on. We're square. We've already checked that. Let's look at the optics now. I'm not touching the optic on the. I'm just cleaning the outside rim here. Okay, as far as the optics are concerned, visually inspect the beam window. The beam window, if it's not dirty, don't clean it. But if it is, what you do is get your lens solution, put your fluid on there, saturate it really well, get in there and gently roll it across the window. Just press nice and lightly. Don't dig into it. Get the dry side, dry it off. It's not that sensitive, but you want to get never push a dry one across there because you might scratch it. Get it off initially because the dirt's what scratches and not the cotton swab. So get the dirt off by flooding it real well and then come back with a clean. Never reuse the cotton swab again. Once you're done with it, move on, get another one. It's not worth it. Take your swab again with the mirror. Inspect it. If it's clean, leave it alone. If not,
Sorry.
it's okay. I did it. Go ahead and slightly saturate it through. You can see some stuff on there.
Yes.
Brown. Go ahead and
What's with the brown? Is it smoke?
smoke from the wood.
I call it muck and mire.
Okay.
If you just wait too long, the beam itself will harm the lens.
Absolutely. What will happen is the dirt that's on the surface
Will heat
will
up.
absorb heat, and that will etch away the coatings of the mirror and eventually cause mirror failure because the mirror will get hotter and hotter and hotter. You'll reflect less heat and it becomes a snowball effect until finally, boom, it blows a hole right through the mirror. Because the mirror is actually made out of glass. It's glass with the reflective surface on the front side. A regular mirror has a reflective surface on the back side. So when you clean in a mirror, you're cleaning the glass, you're not cleaning the reflective side. Laser mirrors are the opposite. The reflection's on the front, not on the back side. Because the laser won't go through glass. It'll absorb it. So once the coating gets destroyed, the reflective coating, it'll just blow a hole through the glass. Now, if you ever have to change this mirror right here, you can see that there's a little notch on the side. You get a very small flathead screwdriver, you pop it in that little gap that's right there, and you pry it out. You go in there and you pop it out. See that? It's a small gap there.
Is it strong enough to withstand that?
No, it's going to break. It's going to break,
break,
but who cares? You're
Okay.
replacing it anyways. It might crack it or chip it, that's
Uh-huh.
fine. You pop it out because there's double-sided tape on the back side.
Okay.
It's just double-stick tape. Now, the new mirror that comes with it is you get a new piece of tape. So pull the old piece of tape out of the back side, put the new piece of tape in there, and then just press it in. Now, don't put your fingers on it.
Right, 'cause,
Use the paper that's with it, and on the front side of the mirror, just push it in. You'll have your paper that's there that comes with it. Push it in until
All
it
the way
sticks
in.
really all the way. It'll bottom out. Then when you're done, go ahead and realign it, okay?
Uh-huh.
with the screws on the back
And
side.
then, oops,
It's okay.
this, these screws are gonna move this silver piece that holds it.
Exactly. You're moving the silver
Right.
piece. Right.
So wherever way, even if it's a little off that way, you're gonna adjust it
exactly.
when you do the thing.
Yeah. So it's not critical how.
What does a mirror cost anyway?
$75. It's not that expensive. That one.
That one.
The lenses are a lot more, like $200. Now, if this beam window here, this is not a mirror. This is a. The reason why it's yellow is it has zinc selenide as its main material. It's not glass. Zinc selenide is a material that allows the CO2 beam to pass through with very little absorption. So we couldn't use glass. Yeah, it's a specially formulated type of thing.
A long time ago, you had nothing there, didn't you?
No, we never had nothing. Our
Oh.
competitors had nothing.
Oh.
And this causes a problem because the dirt would go through the hole and get on the laser's optics on the #1 mirror and cause all sorts of problems. We always had a beam window, which saved us a lot because it protected the optics in the back. Okay, a beam window is a solid piece of zinc selenide. This mirror has yellow coating on it made out of zinc selenide, but the mirror part itself is silver. Okay, it's a silver coating. So you have glass, you have a silver coating on top, and then you have a yellow coating on top of that. The reason why the yellow coating is there is to prevent the silver coating from oxidizing. Because silver will oxidize, like your silverware will start turning
It's
brown.
almost like wearing sunglasses.
It's right, exactly. But what will happen is if people abuse the coating of the zinc selenide or scratch it because it's soft, it'll allow oxygen and chemicals to get through there onto the silver surface, will start to damage it, and the coating will start to peel off and cause all sorts of problems. So that's why the mirror is yellow. It's really not yellow, it's just a coating of zinc selenide. It's actually silver underneath, silver and glass. Okay?
Dirty.
It's in great shape compared to what you'll see at customer sites.
Now, I don't want to get ahead again, but that piece over there is sold like that, or do you
Well,
replace
we
stuff?
can replace individual components on there. Actually, we might as well just talk about it because we're here anyway. You know that? That's the #3 mirror. That's the focus lens. Now they're held onto this plate with the 2 screws. 2 for this one and 2 for that one. Now you can't separate the mirror from the bracket because it's glued. If you get a new #3 mirror, it's called the #3 mirror assembly, meaning that this is glued into the bracket. That's how we sell it. So the replacement is you take the 2 screws out, put a whole new assembly in there like that. You don't want to replace the whole thing if the mirror's busted and the lens is good.
Right now.
Because it's $200 more than what it should be. Same thing with the lens. If you blow a hole in the lens and the mirror's good, just take it out and put another one in. But there's a little bit of a technique involved with that. We have to get it kind of aligned properly on the carriage. But we'll show you that a little bit later upon component replacement. Right now we're just focusing on cleaning, which a customer will regularly do. Now that mirror, is it dirty? Well, take a look at it. Take a good look. Hold on to it. Move it around. And where the beam is going to hit, it's going to hit in the center.
It's only one smear there, but
There's
it's
a little
mostly
smear.
on the outside.
That's all right, the outside. Is the outside bad?
It's all-
No, the outside's not bad. We don't really care too much about the outside. The beam's going to hit in the middle. You can sit there and clean the outside if you want to. It doesn't really matter. But that, as far as that little smear in the middle, no big deal.
No big
I
deal.
mean, if you can't, if you see a really good haze there, you definitely want to get it cleaned off. Some people become over-compulsive about clean the mirror too much, scratch the coating, which damages the inner surface and causes it to fail faster than if they let a little smear on there.
Counterproductive.
Right. Okay?
So whether countersunk so that goes to the same spot when you...
Almost. It's not a perfect countersunk. There's a little bit of slop there.
So replacing this also involves another...
A little check. Yeah, we'll do a check with it. Make sure that that's going right. Okay? Okay. So let's say we had to clean this mirror. We do the same thing. We get a fresh cotton swab. We come in with our solution. We saturate it. We go in there.
That's my stupid phone.
Oh.
There's like cool sounds on there.
Little gadget.
Very gay.
Excuse me? Touch your teeth. Okay. So now we get that clean. Now you're going to run into a situation where by using this cleaner, you're not going to be able to get all the schmooey off that's all over the mirror. That's generally because the schmooey may be composed of plastic material. Wood comes off real nicely, and most organic resins come off nicely with this cleaner. But you're not going to get chemicals off with this cleaner. And you can use acetone to get the haze off of plastic residues. Because if you sit there and play with it and start gouging at it, you're going to start scratching it up. So the haze is kind of coming off here, but I'm sure that I would get it a lot cleaner is if I took some acetone.
Do you want me to get some?
So it won't eat it up, huh?
No, acetone won't eat it up. Now, you want to use straight acetone, not nail polish remover or anything like that.
Oh, I have some. I just don't know where.
Okay, well, you get the idea. Just as long as I'm telling it to you, you can get that residue off. I've got it fairly clean, but it's, by all means, you hold it at a certain angle, you can still see a little bit of that, not alcohol, acetone. See a little bit of streak there?
Up and down.
Yeah, I'm going to put that back on because I'm going to still show you component removal and replacement. Okay, as far as other basic maintenance is concerned, you clean the window with soft cloth. Sometimes paper towels can cause scratches. If you got it saturated really well and be careful with it, you're not too bad, but it depends on the quality of the paper towel too. I like to take
Windex on that.
no Windex. I like to take a terry cloth, wet it down, clean it gently, do strokes in a certain direction to get the initial haze off, come back and do a cleaning pass. Because after a while, if you
Soap
start...
and water on that, or what do you want?
Soap and water is best. Because after a while, you start cleaning it hard, it starts to get little scratches in there, and then after a while, it gets so foggy you can't see through it anymore. So...
they sell replacements for that.
Yes, we do, but it's not cheap, and it's not easy to get off as far as changing the window, because there's special screws here, tamper-proof screws that prevent people from operating without the... Yeah, so you can get it off. You have to use a very sharp needle nose pliers. I suggest you grab it and kind of go slowly with it to get them loose, and then take them off with your fingers. Okay. Okay. Now.
Okay.
My cousins, they were coming here and sleeping over tonight.
That window's kind of dirty because the dirt has gotten behind in between this piece of plastic and the board. Now normally that's not a regular maintenance thing that a customer does, but you happen to be there and you want to clean that out. What you do is you poke your head over the side and you're going to see a plate there. You're going to see a black plate. Everybody take a peek over there. You see this big black plate?
Yep.
Okay. Okay, take a look. It's a black plate. Okay, it snaps out. So if you get in there, go ahead, take a peek. See it? You push it down like that. Sorry, I'm just kidding. It snaps down like that, and also the board snaps down too. There's one little ribbon connector right here, so I'm grabbing it with my two fingers, and look, voila, there's the ribbon connector. The board behind it snaps down, and I can kind of get in there, clean it out a little bit. Okay. Hello. Okay. I'm losing it. I've been in Yugoslavia too long. Okay.
Are you getting tired, Vince?
No, not at all.
No? Okay.
I do this day in, day out.
It's what I do.
It's what I do. Hey, here we go.
Hello.
Should have been a teacher.
You need to
That's
fly
what you
like
want.
Tupelo Airlines.
He is
or
the
something,
teacher.
I know.
I like
That
those
is
Russian.
Ooh, that looks worse than when I clean my ears.
Just the one.
Oh wow,
Potatoes.
my machine hasn't seen the light of day like that in a long time.
Look at that.
Mucking Maya there.
A clean machine is a happy
Happy
machine.
machine.
The little smiley faces. Okay.
Oh, you missed the corner.
I know. I have to get another one.
Oh, Julia,
She's good. She's good.
you're good. You're good.
She's very good with the cleaning thing. I wish all our customers take lessons from Julie. We'll have Julie do the training. All right, get your rubber gloves out. Let's go.
I don't care if the machine works as long as it's clean.
See, it still has some stuff in there. And you can also hit the window part of it too.
32.
I know. Would you stop? It's a lot cleaner than it was before. And you got to plug that back in. Oh, by the way, while we have this thing off, if you ever have to change the display board, just keep popping it off. I popped it with snaps like this. It will come out, see? Just kind of wiggle it around down there. And here you go. Here's the display board.
I've done this.
Comes right out.
I'm glad the kids are enjoying this. I was kind of worried they
A
were
couple
gonna...
of snaps. They like taking stuff apart. Destruction is.
Putting it together is another thing. Huh?
There you go. Have a board.
Have a board anymore.
Okay, here's this other. This is just a protective cover, this black plate. If you ever have to replace this, all you do is take the board out like this and take your hand and push on this window really hard. It's just a sticker. You push real hard and it peels right off. Just has double-faced tape on the back side.
But that is a keypad panel.
Yeah, but it's a sandwich. Okay?
Oh, you mean underneath here?
There's nothing.
When you take that off, you're not taking any electronics off?
Nope. Nope, it's all embedded.
Just push this
Just
out.
push it
It's
real
gonna
hard
pop.
into the body of the thing. So you take your cable, which is hidden over here, there, and you plug it in. And it can only go in one way. Snap it together and then pop it back in. I'm just going to do this to save time, just so you understand the concept. It's not that we do this often.
Very, very rarely.
Yeah.
I've only done it once or twice.
That's because yeah, it was defective. Yeah.
They don't go. If that board goes forever.
Martha Stewart, I don't believe it. Oh, we got the board back in. We're ready to go. Now we can see again. You know, that's a great thing. Okay, what else do we do for as far as maintenance is concerned? Let's take this door, open it up. Oops, sorry.
All right.
John, we're gonna show
Now
you
you see how nice this is?
It's a perfect fit.
It's a perfect fit. Now what's going to happen is when you put these legs together, chances are the door is going to hit the legs. Okay? Because when you assemble everything, you don't necessarily get the legs perfectly
So
vertical.
before you tighten it up.
Get all the screws together. There's 2 screws that connect the panel. You'll pull the legs out, tighten the screws so that they remain straight. Because most of the time what happens is your legs kind of kick in a little bit when you're first putting them together. Just yank them out and tighten the screws in the back. So the concept is make sure your door swings freely between the legs. You shouldn't hit it because you'll ding the front side and the paint will come off and all that kind of stuff. So it should swing freely. Okay. Here's a cutting table, which is an accessory that goes on there.
Heavy.
No. Okay, here's the regular engraving table. And we've got rulers down here. As far as cleaning inside here, you've got a couple of lead screws for the Z-axis. They have a little bit of grease on them. Okay? The grease is white lithium grease. We're going to go ahead and turn the machine on. And we're going to run the table up and down. Now, if the table starts to chatter or make all sorts of weird noise, that's going to tell us that we need to wipe this grease off, wipe it off with a towel or something, get some fresh white lithium grease at Ace Hardware or something, Home Depot, and put a dollop on your finger and just run it up and down the screws, just saturate it, and then run the table up and down to work it in.
All 3?
All 3.
I'm surprised they want white lithium grease.
What?
I mean, with engraving equipment, grease always attracts debris. Like, we always use like a break free or a dry flow or
Yeah. The dry compound. As opposed to wet. It works for us. People don't move this table up and down.
we have an engraving equipment.
That's your
People
motion.
lubricate it. They put so much on there, it's like
lead screws to drive your motion system, right? We're not. We just
Right.
move the table a few inches here and there.
Yeah, that's true.
Whereas if we had it on the X and Y, yeah, I can see what you're talking about. But here it's no big deal. And maybe they'll re-lubricate that once a year or something like that. It's no big deal. What can happen though is you're right. There's people who do a lot of particulate cutting, like small pieces of paper, stuff like that. It can stick to it and then get all over the place and cause the table to bind up because it gets jammed in between the screw and the nut and cause all sorts of weird problems. So if they keep the system clean, they vacuum it down using these little pieces of material, don't get stuck all over the place.
So you just put that in Z mode and then move the table
Yeah,
up.
so all you do is press Z. Yeah, now you're in Z mode and this lowers the table.
So right from the ready status you did that?
Yeah. And this raises the table.
And then you change the speed of that when you're going to focus.
Right. We'll cover focusing and stuff like that. But for right now, I just want to just drag the table up and down to see if it chatters or makes noise, and it doesn't. So that's great. I leave it alone. However, it does look a little bit dry if I'm at a customer site or something like that and I have some grease on me. I just slop a few more valves on there.
Limit on the bottom?
It will stop at the bottom because we do have a home sensor that will limit it at the bottom. See? And then we have one at the top too. You can see it right here. If you look down here, there is a flag. Here's a flag there, and the sensor right there. Actually pretty dry. And over here is an upper sensor here. Alright? So that stops the table up and down from slamming into something. Now what can happen is if those sensors get dirty, like rubber stamp customers or customers use a lot of debris, it can clog the sensor and it might think that the flag is actually in between the two sensors. So it won't move in one direction. Let's say, for example, that you're over here, right? And the bottom sensor is dirty. It thinks that the table's all the way down. So if you try to go down, it won't go down any further. But it always goes up, but it never goes down.
Now it can't go back down.
Right. Then you know the bottom sensor's dirty. The same thing with the other. If it won't go up, but it goes down, then the top sensor's dirty.
Yeah, the problem with that is you got to turn the machine off and turn the screw with your hands just to get at the sensor.
Well, that's what I was going to say. That could be a problem if the table is in there and you can't get it out. Or
You might have a situation like that.
You just turn it with your hands with the machine off till you get the table up, clean the sensor out.
There's different ways
How
that you
would you
can
use the cleanest sensor?
Look, I'll show you that. There's different ways to move the table. Now you can grab the belt here, move it up and down like that.
But you missed it, though.
I did.
Okay, you can move it up like that, or you can reach in there, get your hands dirty, and turn the lead screws if you get enough grip on them. Or on this side, you can turn the lead screw, or you can turn this belt that's attached to the motor. Feel that belt in
Yeah,
there?
feel it in there. You just pull it out.
Yeah. Right. You're in an awkward position. It's easier from this side.
Okay.
And then, or you can do it from here. You can rotate. See, I'm rotating the belt right here. Here's the Z motor right here. There's a little belt right there.
Okay.
And there's the screw there. So I'm just rotating with my fingers, and it's moving, see?
Oh, I see. And so that motor could possibly go too. That could be.
This could go, this motor, but we never change Z motors.
Very rare.
Never.
Now there was a red and a green light under there before I just
Yes,
started.
that's the autofocus sensor. We'll cover that in a few minutes. But let's say you do have a problem with the Z-axis home sensors, okay? Well, we have to take it out. I have to show you how to take it out and A, clean it, or B, replace it. First thing I'm going to do is I'm going to turn it back on, and then I'm going to bring it down as far as it can go. Then I'm going to get my Allen wrench. Turn it back off. Raise it up. There's one screw right here and one screw right here. Take those two screws out, the whole board comes out, which is nice. There were some older units that we had out there that had wires connecting back there. It was just a disaster. But I yelled and screamed loud enough to get them to make me a circuit board so that we can pull the whole thing out in one shot.
This I've never seen.
It's good.
So you can basically just clean it.
There you go. Now, this is the home sensors here. Now, these are optical sensors.
See, those are the U-shaped things we were talking about.
Right, it's the same on the motion system, okay? Now, there's a slot right there, and there's a slot right there. There's a light that shoots across the groove. It's infrared. It's not like a visible light. So it goes from one pole to the other. If these grooves get clogged up with stuff, it's going to think that the flag is in between. So what I do is take some compressed air, like in a can, and you get it at the computer stores, spray it in that groove, spray it in that groove, and that should clean yourself up.
Okay.
Same thing with the upper one. If
Can't you use a Q-tip with alcohol?
Well, you can, but the problem is you're going to get it wet. Okay, if you use alcohol, it'll dry pretty quickly, and electrically it shouldn't short out. I'm more concerned about it getting shorted when you plug it back in. You know, if you do use a fluid in there, try to spray some compressed air to dry it out before you plug it back in, because you might short it out. But usually just compressed air will go ahead and clean that up. If you can't get it clean, no matter whatever you do, just replace the whole thing. Put another one in.
And you always know it's on top because this is the connection.
Well, the only reason it's only going to go in one way for you, and you can only plug it in here, so you can't put it in upside down. So you're going to go ahead and plug it in. I like to plug it in first.
The hole should line up pretty good.
You okay with that?
Easily.
Yep. You slide this over here like that, and line your holes up, screw it in, and away you go. Again, this is not common either, but I'm showing it to you anyway.
Yeah, it's very thorough.
Now then we're gonna rip apart the X-axis arm, which is the most common thing to do, as far as maintenance is concerned, because that's where all the wear.
The bathroom break for that one.
Okay, that's where the wear and tear is. Part once he gets out of the bathroom.
They
Okay.
get sucked out
Yep.
Outside.
accidentally. Oh, they did accidentally.
We're gonna cover
Cool.
removing of this plenum and how to clean it.
Honestly.
Okay, we'll do that later. Ready? All right. Now, let's do the X-axis. This is the most movement that the machine will make. The machine hardly moves in this direction. It can move 1,000 times back and forth before it makes one revolution of these bearings. So, here's all your wear and tear. These 3-axis bearings and the belt itself. Now, the belt, half of it runs on the outside, the other half runs on the inside. We don't care about the inside. Can't get to it anyways. Where your belt is going to wear is only from here to here. It's not going to wear on the inside because it's not contacting any geared surface. And it's not going to wear on this side because it's going around in either pulley. There's no teeth being meshed up against it. Only on this side will it wear. So if you're inspecting for belt wear, you inspect this belt on this side, not on the other side. And how you inspect the belt is you just pull it out and you look at it. Now, let me explain the shape of this belt to you on the board. The belt is shaped like a trapezoid. This, angle, flat, angle, like that. That's the teeth. Obviously, the gear is the opposite shape.
On the motor.
That's attached to the motor. Okay? This is the belt. When the belt starts to wear, the flat part of the belt starts to wear away and it becomes triangular shaped like this. So this starts to wear off and it becomes little pyramids. So what happens is when the gears turn one way, it pushes the focus carriage to one side, and then when it goes in the other direction, it pulls it to the other side. So what happens is when it goes to raster engrave, it slightly sways back and forth. Then your left and right raster lines like this don't line up edge to edge with each other. They start doing that. So everything starts to look fuzzy
Only because you have a little play in this.
because you got to play. Okay?
That shows up at the ends of the sentences, ends of the characters.
It shows up all over the characters,
That's
actually.
true, too.
Okay?
Because each thread.
Because each pixel, the whole line is shifted. So this is what we call a double image or fuzzy engraving. Can be as a result of belt wear. So you pull the belt over and you look at it, and you look to see if there's still flats on the top of the belt, or if it looks like a triangle. You'll definitely see it. Because what you should do is compare this side, which is a fresh side. If you take this down and you look at it real close, you can see the flat parts at the top. Then you push this over here, and you take a gander over here, you see, oh, look, there's still flats on there, too. This belt's in great shape. See? You see the flat part of the belt? Now usually what happens is a lot of people who do a very small amount of engraving will engrave everything in this upper left-hand corner, just like this, all day long. Little plaques here and there. So when they go to wear, what's going to happen is they're going to wear out the belt right over here. So you push this over to the side and you take a look at it, and you see all the wear from like here to here, and then it's all clean over here.
Because that's where the motor is.
That's where the motor's, that's where the teeth are.
That's why it's wearing
Belt
out.
over if you want.
No, you can't really shift the belt. They can shift their engraving.
That's
So
true.
you say, hey, stop engraving over there, move it over 6 inches. And then they can get more belt wear over here. And keep shifting it over until they get the whole belt worn out, and then replace it. Or A, or B, replace the belt. Or C, instead of just always engraving in the same area all the time, use the whole field.
So they would change 0, 0 then to move it down, right?
They could, or just move it on the screen.
Uh-huh.
Start everything 5 or 6 inches over.
Which is one of the tests you do with them over the phone.
Right.
If they're saying it's bad quality up here, just say, do me a favor, take
Put it
your
over to
thing,
the
put it on the bottom right, and tell me if it looks different. And then they do that, oh, it looks great. Now you
Change
know
the
it's the belt. It's very simple.
Yep. Absolutely. Because then you know they're doing a lot of their engraving
Right.
over there. Simple.
Small shops.
Yeah, small shops tend to do
individual
that.
things.
Onesie, twosie things. Okay. Well, let's say we had to change the belt. Okay?
You can't take that belt off and put that same one on, right, Vince?
No.
Bless you. That's too hard, right?
It's too hard.
You sneeze just like your dad.
You can take one
Great.
Let's go ahead and take a look at this. You see a nice fresh belt. You can see
So
it's,
what doesn't look the same?
it's the same.
My eyes.
It's an optical delusion. But you can see how it's shaped and how it's formed and the trapezoidal shape and the flats on the top and all that kind of good stuff. Okay? We're going to change the belt, but before we change the belt, we're going to take off the focus carriage so we can get to the belt. And then we can show you how to change the bearings too. So we're just getting this ready. We're not going to do that yet. So let's change the bearings here. Now there's two ways to change the bearings. You can completely remove the focus carriage and take it out and change it out here, or you can just kind of lift it off the tracks and change it right on the spot. The simple way is to just lift it off the tracks and change it. Now to do that, you just lift up on it and unhook it. You see, because this is a spring-loaded pivot arm right here. So I can reach in there now, my trusty little tool,
We're going to reverse the bearing. Is
loosen
that
the screw. This one's on backwards, the other one's correct.
I was always going to ask.
Which one is right?
Where's the...
The fat side, the part that's sticking out, goes towards the head of the screw. Okay, so you can see the bearings are not symmetrical. They're not. They go in this way. Now it's a three-piece assembly. There's the screw, there's a small little wave washer looking spring.
Reload.
It's preload, right. Now sometimes what happens over a long period of time is it gets a little flat. So I take the thing and bend it a little bit because it's just a little piece of soft metal. So I get in there and I bend it to make it nice and strong. You can see how it's not flat. Then I put that back on and then put the bearing on. Now when you get bearings as a replacement, you have a choice. You can get just this unit fully assembled like this, a set of 3, or you can order one at a time, or you can have what's called an upgrade kit where you have all of these pieces, the three pieces.
They come together, yeah.
Yeah.
I was at a job one time where I
You might
couldn't
lose
get,
the spring. Or
I
something.
couldn't get
that out.
that out for
It was
nothing.
frozen. Yeah, because then
frozen
you would need the shaft
Yeah.
and the spring
Yeah.
and put it in like that because it should slide nice and
So
easily.
it should
Oh,
slide
yeah.
out nice and easy.
Yeah.
Yeah, I was there. I was, very confused that naturally.
Sure.
I thought it was going to come off, and it just didn't.
Yeah,
So I had to go in the bag and get
get an assembly.
an assembly.
Okay. So that's what bearings look like, and we put that spring in there to preload it. Without that spring, it's going to wobble all over the place. So you got to have that little spring in there. Okay.
Okay. I want to see that again. Just
Oh yeah. Well, what we'll do is now I can sit here and change all three
Spring.
and take them right out.
What spring are you talking about?
The one that's on the shaft spring.
This
Yeah.
bottom one?
Little
Yeah.
let me
weedy
see
one.
it.
The wave washer, right?
Let me see it.
Now, instead of working on it like this, hanging out in the middle of space, we're going to take the whole thing off. There are 4 screws on the right-hand side of the carriage. 1, 2, 3, 4. The 2 middle screws detach the belt and separate the belt completely. We don't want to do that. We want to take the carriage off from the belt, so we're going to take the 2 outer screws out. So the 2 outer screws allow the focus carriage to come off. You'll see in a second once I take it out. 1.
Now you're just doing this in case you want to change the bearings.
Well, I'm going to take the whole carriage off so you can... Here, see? That's what I wanted to do. See, now the belt is still clamped on with this little clamp here. We didn't let the belt go. We just attached the carriage from the belt. If we want to change the belt, then we have to release this clamp. So
This
here,
this is the correct way.
that's the correct way.
The one thing to notice on that carriage assembly, take a look at the spring. This. This is a common thing that when you put it back on
Yeah,
again,
you see that? You see that location?
you see this here? This is a common thing that, Larry, want to pay attention, please?
Yeah, you got to teach them over there.
This has to go on like
The
this,
inside.
on the inside, but a lot of people will go like this and click it back on for the outside. That's wrong.
That's wrong.
Because you lose your spring action.
You not only lose your spring action, it
There's
won't
no
work.
spring action on this.
There's no spring?
I don't think so.
I get spring action. This
Yeah, it's here.
Is it there?
Yeah, it's just kind of hidden.
Is it flattened down?
It's
or?
flattened out. So let's take it out. Here you go. Here. Don't drop it. Give me your hand. Bend it a little bit. Get in there with your nail. Just kind of tweak it. Make it unflat.
Does the screw node stop at a certain point?
Absolutely. It's a machine.
Otherwise, it make that washer useless, right?
Absolutely. It's a machine shoulder screw that has a specific distance there. Okay, you got it?
I got it.
Where's the screw?
I don't know.
Oh, yeah, just teasing. Okay, put the spring
Thanks.
on the shaft of the screw.
Yeah.
And then put the bearing with the thicker part sticking out towards the head.
It's on me right now. That won't go in. I gotta. Oh, there it goes. Okay.
It's a tight fit because it's
Yeah.
very.
No, I didn't know what.
machined
I didn't want to
perfectly.
force
Yeah.
anything.
Okay. And then the last one. Here, go ahead and do the same thing for the last one. Take it out, bend the spring a little bit, stick it back in. Just put a little preload on there.
You want to try one there?
There you go. Do it.
Yeah.
I'll have Kevin stealing the show here.
Oh, yeah.
What are you laughing at?
What are you laughing at?
Come on, tell us. Tell us. Was my fly open or something? Oh.
You were doing something and then he said, Kevin, clamp it.
Come in, clamp it.
Who said that? You said that, Larry?
I said
I
what?
did.
Oh, John said Kevin Clampett because his last name is Clampett, meaning Clampett.
Oh,
My name is Clampett. I was meant for this business.
that's right. Okay, get the spring on the shaft. Slide the bearing onto the shaft.
So what you're doing first is kind of bending that spring a little so it has a spring
I
action?
like to, because after like a year or two, it's going to get flat just from it's just a piece
Just a
of
little
metal.
resistance. That's all.
Yeah, just we want it to push on it. It makes the bearings roll a little straighter.
but we want to sell more bearings.
So
That's not really a part of the
the
thing.
fat bearing goes against
The head.
the head. Okay. Yeah, you're right. It is a very tight fit. They machine quite.
There's a way to put that little
Force.
spring on.
That is by direction.
Either way.
You get it? You haven't checked. Maybe a little.
There you go. Hey, supermarket glasses.
All right. We're going to go ahead and put them back on. Any which order doesn't really matter. Get them in there. And then when you go to tighten them up, don't go nuts on them, you know? It's just a piece of aluminum there. You don't have to screw them in that hard. So take your thing, tighten it down. It will stop by itself. Just put a little on it. Just, okay? This in there. Just,
Don't
That's
use a
all.
3-foot ratchet on it.
No, no cord branches or pipe branches or anything like that. Now we're good. Make sure that we're turning good, and that it doesn't. It shouldn't flop around back and
Is that
forth.
aluminum body or is it?
Yeah, it's aluminum body. So you take it, you grab it, you move it in and out. Make sure it's not going like this, because if it is, something's wrong. So grab it with your fingers and kind of pull it back and forth. Now you should feel it spring, but I mean light pressure.
Yeah.
But what'll happen is if you pull it out, see it bounce?
Mm-hmm.
Okay? But it should be snug. It shouldn't.
Probably shouldn't go the other way. That's for sure.
Definitely shouldn't go the other way.
I mean, when you let
How
off,
often
it
does that assembly that holds that bottom bearing go? The spring.
No, you don't have to worry about that.
That
Never change that. Leave that alone. Matter of fact, don't even take that apart. Okay? There's like 7, 8 washers and stuff. And you'll
Right.
never get them back. Yeah, they'll be all over the place. You'll lose them and you'll screw everything up. Don't take that screw out for any reason. You'll be in trouble. It should pivot. Let's say you run into a situation where you grab this thing and it's not doing this. Just take some oil, just some whatever light thin machine oil, something, put it in there, and just kind of ratchet it to loosen it up. Okay, that's it. Don't take it apart. It'll be a mess.
Uh-huh.
It's a very precise fit on all of this stuff, so that it has minimal movement as it's hauling butt back and forth like that. Okay, now we're kind of done with this carriage. It's all clean and beautiful. We're going to stick it over to the side because we're going to change the belt now.
That's hard.
No, now
That
we
was
need,
easy, actually.
we need our scientific equipment from Staples. You got a stapler?
Yeah.
There we go. This is our piece of scientific equipment. And we get our new belt. You always have to have a new belt. You cannot change that belt and reverse it. Because I told you it only wears on one side. People say, well, I want to use the other side. You can't. You
'Cause it's
can,
not one piece.
you can reuse it as long as you have one to swap it out with.
And belts are cheap, so anybody who
Belts are
did that is a really cheapskate.
Yeah. But the question's been asked many times. So what we're going to do is we're going to
Bob Wood would do that.
take these 2 screws out. Now we don't have to take these screws out all the way because it's going to release. I'm going to unscrew them halfway, and all of a sudden the clamp will release and the belt will slide out. Like that. Clamp still together. Now we've got this going on. Okay, now don't twist the belt or yank it out, because people have done that before. They'll take this, say, yeah, pull the belt out. Okay. And you're going to have a hard time getting it down the center of this pipe. I stood there for like an hour. I was in Israel. You know, the guy did that. He says, I can't get the belt back. And I happened to be there on a visit and all that kind of stuff. And I sat down in the street in the sunlight trying to fish this thing down because I had no wires. I had nothing to do this with. So what a pain. So the answer is, what you do is you get your stapler. You get your ends like this. Butt them into each other. Don't overlap them. Just kind of butt them into each other like this.
Same direction.
Same direction, absolutely.
Now you do.
Put a staple through. 2 of them. 1 for good luck. Okay? So that it doesn't come out on you.
Maybe the elastic comes off of the shorts. Then you have to put a safety pin like that to connect it.
There you go. Women can relate to everything. Okay. Now, slowly pull it through. Don't twist the belt during the process. Okay, hold it.
When it gets to that turning point, go nice and easy.
Absolutely. You're going to feel it catch at the end, but usually you can get it through. Voila, look at that. Now everything is great. get your staples out of there.
You need a scissor.
Not yet. Okay, make sure you didn't, still remains untwisted. Now there's going to be extra belt. See how much more belt there is? So with the belts assemblies, the kits that we sell, there's a lot of extra material here. Now if you look at the clamp, it's got a rounded end and it's got a flat end. You want to push the rounded end in because if you see the natural way it's going to go, the belt's going to follow the edge. We don't want a sharp edge there because it will start ripping the belt. Now, what I did was I put this on upside down because the screws have to be on the outside.
Right, okay.
Now, you're going to see on the newer models, the screws are actually on the inside. The reason why, what has happened to a lot of folks, is that when they go to take the focus carriage out, they accidentally take these two screws out instead of the other two screws on the outside, and then the belt falls apart and they freak out. They don't know what to do. So we took the screws, hit them on the inside, so from the outside you can only see the ones that detach it from the carriage. Okay. So you have a lot of extra belt material to grab onto and pull, but that's not how we tension the belt. In this particular model, we tension the belt by moving the motor in and out. And we're going to go ahead and show you that. But for right now, I'm just going to secure it
Probably
temporarily.
best to normally move the motor in before you do it, right?
Yeah, but there's a lot of movement there.
Should you get it as tight as possible with your fingers?
No,
Before you,
just
no.
kind of leave it loose
Okay.
right now. But we have to take the motor out anyways. Make sure that we're moving here. That's telling me that I didn't get it twisted or anything like that. Okay, let's take a look at this motor. And also we have to inspect the drive gear and stuff like that too. This is just an easy way to quickly change a belt. Bada bing, bada boom, you're done.
And then
we'll
use the
adjust
little
the
Allen
belt.
key in there to tighten her up.
Yep, we'll show you that. So, in order to get to the motor, we need a screwdriver. Trusty Phillips head again.
You guys want something to drink?
Nope.
Yes, you want some water?
Yeah, I'm fine.
Want something to drink?
Water.
Water?
I'm a water freak.
Soda? Water? Vince?
I'll get some water.
See?
Water's okay.
2 waters and 1 soda. So you can
3 screws on the top takes the cover off. Okay. Underneath the cover is what we call our upper flex board. The upper flex board, the flex cable, and the lower flex board. You can take off the flex cable by pushing on the button that's at the end, squeezing it. It's just a tab, a locking tab, and pulling it out. Okay.
Ever go bad?
The tab?
No, the cable
No,
itself.
never changed the cable. Very little movement in this direction. That's why.
That's right.
Okay, we take the 3 screws out here on the top. 1, 2, 3. And now the flex board comes off and gives us access to the motor. Look. Another tab. Here's our flex board. It has the 2 home sensors. The Y. The flag goes through here. This is the flag for that. And this is the X. It's a tiny one. So it looks mechanical from the top, but it's really not. It's optical.
Sometimes, especially on new installations, you have to put alcohol on this. I don't know if that's right or wrong, Vince.
What?
But-
Use the sticking on the new ones?
Yeah, it's sticking.
Which model? M?
And 300s.
M300s?
Well, right around here
Which
in the
cause-
end.
Yeah, you got to put a little alcohol, clean it up. It works fine.
I didn't know this.
Only recently.
Okay.
So would that other one have to ever be cleaned over here, this one?
Same concept, yeah.
Same
Blow a little air in if it doesn't home in a
And what'll
while.
happen is you'll turn the machine on, and it'll actually come over and just kind of stop and then move the other way. And that means
Thinking that it hit it.
Thinking that it hit it already because it's already blocked.
so that means that went off prematurely. The plunger, we call it the plunger.
So what happens, right, when you home it, the first motion it's going to make is supposed to go this way, block the path, come out, and block it again. But since it thinks it's already blocked because it's dirty, it moves this way. And it keeps going for like 2 inches.
What's actually the X that was off?
Okay, but I'm saying the Y
Off
right
the
now.
Y
If the
off.
Y is clogged, it's going
Right.
to move 2 inches in this direction and stop because it knows if it hasn't cleared the flag in 2 inches, it's not on the flag.
Right.
So to prevent it from slamming into the front, it'll just move 2 inches and stop. That's our diagnostic to tell us, hey, the sensor's dirty. Same thing with the X. If it thinks it's clogged like that, it'll move 2 inches that way and stop.
Many times with the Y, it actually goes bam, 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 bam. It just keeps
Thank you.
kind of slamming against it, looking for its home. It can't find.
find its home.
Can't find the home.
Thank you.
That's usually because the sensor is physically broken.
Right.
And what has happened there is somebody has bent this flag and homed it one time, and it hit the plastic like this and snapped it off, and they didn't
Right.
even know it.
Right.
So now the next time they go and turn on the machine, it goes bam, bam,
There's
bam.
nowhere.
Because
That
it's-
is so true.
Sometimes.
Now, is that what those 2 screws are there to replace that flag?
well, you don't have to replace it, just bend it back straight. Look, see
Oh,
it's
I
bent?
see. Uh-huh.
Put it straight now.
Oh no.
Yeah, there you go.
Poor
Oh no,
flag.
I bent your
See,
flag.
see how it's bent? Snap. Uh-oh.
Now the newer flags on the newer machines, they're thicker, so people can't bend them as easy. So we had this problem, we corrected it. Okay. But on the old
Why didn't they
ones-
bother doing a mechanical switch? Is that just because it is?
These are more accurate
Are they?
in theory. Realistically, I don't think that they are, but engineering is just fixed on these things. And actually, it's not so much engineering; it's the owner. He wants these things. Whatever. Can't fight City Hall sometimes. We make sure that it doesn't stick as far as the plunger is concerned. As Vincenzo said, maybe a little drop of alcohol or something in there. It might get a little gooey, and there might be some glue or machining residue probably. I have to talk to them about that. We did redesign this plunger on the newer models, so instead of it being one plunger with a flat on there, there's 2 rounded pins, so it won't stick anymore.
Okay.
But since we still make M300s, we have to watch out, make sure that that plunger's working correctly. Okay, if that board goes bad, just replace it. Simple enough. Here's the motor. X-axis motor. Now you notice that the motor's mounted with 4 screws. 1, 2, 3, 4. There is a plate that's mounted underneath. So these screws actually go through this plate, go through the plate, and attach to the plate down below. And the plate down below slides back and forth like this, so you can provide tension for your belt. So what I'm going to do right now is show you motor removal and replacement, just in case you have to change a motor.
The motors do go.
I did.
Yep.
Yeah, you did one.
Remember over in Hartford at one on there.
Yep. So
Now, we had a problem with these motors. I want to tell you that right now. Because of the design from this manufacturer, we had a problem with this, and I want to show you what the problem
Stepper
is.
motors? Or they?
These are stepper motors. Now, the motor wasn't really bad. The problem with the motor is that the glue that holds this cap on went bad and caused the shaft here to go cockeyed like this and have the motor bind up.
Have a high spot. Like,
Yeah, right.
That's when
That's
I
exactly
replaced
what
it. That's what happened.
that's what it was.
Now, because if you get this thing, you clamp it back together, the motor's good again. So what we did to redesign this is they got rid of this glue, because after a while this glue would get hard and brittle, and then it would pop off, and the motor would seem to fail. But it's really okay, the motor. It's the cap that holds it together was the problem. So we have a new motor design here. You can take a look, and you can see the drive gear and everything there.
That's one of the older motors here, right?
Yeah, that's one of the older motors. Here's the newer motor. I'm going to put this on for you,
Ooh, lovely.
and you can keep that as a spare.
Lovelier.
Oh my goodness, all these Christmas gifts.
Yeah. Now, what you don't really... It looks like it's not very different, but it is. You see this black thing? Okay.
Is that rubber?
It's carbon. It's a solid piece all the way through. So there's no cap here. The glue
Oh,
is
that's
there.
nice.
The glue is there just to seal it from dust.
Much nicer.
But the whole thing is a solid piece, so it won't rotate and pop like these little pressed-on caps of metal. So that's preventing the problem from happening now. Okay.
Yeah.
Now, if you change a motor, you got to transfer the drive gear or put a new drive gear on. Believe it or not, the drive gear can wear, even though it is aluminum. If somebody does very abrasive things like lots of marble or anodized aluminum or glass, just the dust getting between the belt and there will act like sandpaper and file off the teeth of the motor. Let's say you've gone through 3 belts, you might have worn out the drive gear too. So you might have to change the drive gear. To change the drive gear,
That may be causing belt wear.
that can cause belt wear too.
You know where it fell?
So to change the drive gear, get your Allen wrench, and we'll take off. It's okay. We'll take off the drive gear. There's a 1 screw right there. loosen it up. Now notice the position before I take it off. You see how just a little bit of it sticks out? Just a little? When you replace it on the new one, you want the same thing to happen.
Yeah, that's really critical because it's easy to put that shaft all the way flush
And cause a
against the
problem.
motor, and then you don't
not
realize
good.
you did that.
So inspect your teeth. Make sure you got flats on the top and no triangles, just like you would on the belt. You can inspect it from the side.
Sharpie over there.
And you can see that we're still okay.
You know,
You
I see
definitely-
I see some of them pyramiding now. A little bit.
Yeah, after a while. The teeth on those are never going to be perfect because it's knurled. But trust me, that's in good shape.
Was this rolled? Like a-
Yeah.
oh.
Yeah. So what'll happen is you'll really see severe damage there if it's severely damaged. You'll notice like,
You guys
wow,
make all
there
your
you go.
parts at your place, like those?
No, we don't make anything.
No?
We're not a manufacturing facility at all. What we do is we design everything and we have it all. We job everything out. We bring it all into our factory and we assemble it. So the only thing we have is a bench grinder and a drill press, just in case we got to modify something. It's like making Ferrari.
Even the cases
But isn't
and
that the
all
way
that.
of any business? I'm sorry. Isn't that the way of any business though? Like you want to try to reduce your cost by making things yourself? And I'm surprised that.
That doesn't necessarily reduce your costs.
No.
Not on a motor.
Because you can invest a lot of money in CNC machines and personnel training to make these things happen.
Just go out and try to find the best parts in the
Yeah.
market.
Yeah, the best parts, get them manufactured in high quantities, reduce your costs, and away you go. So the whole idea is to sell a lot of machines so that you can bring the cost down.
And have a lot of the parts being universal if you sell different.
Right. Like, for example, this gear goes on all our different
Every
machines. It's the same machine. These bearings go on every machine. There's a lot of cross
Which is great for service because you can go and really one machine and almost have the whole thing.
Exactly. So I'm going to put this gear back